Introductory Market Trend Forecasting. In this lesson, we will learn how to use real-world datasets to forecast market trends using Python. Market trend forecasting helps businesses understand future customer behaviors and industry movements. You will analyze datasets to identify patterns, segment customers, and make actionable business recommendations. We focus on practical analytics scenarios such as customer churn, campaign responses, and purchase trends. Running the cell now. We import pandas to manage our datasets. NumPy is useful for numerical operations and random data generation. OpenML helps us load real datasets from online repositories. Matplotlib helps us visualize trends and data relationships. Seaborn provides advanced plotting tools for analytics. Importing warnings lets us suppress any unnecessary warnings. We suppress warnings so our output is clear and focused. Running the cell now. Understanding core market research concepts. Market research data often includes customer demographics, behaviors, opinions, and time-based transactions. Survey responses may be categorical such as preferred brands or numeric such as satisfaction ratings and NPS. Customer analytics datasets may also capture purchase and campaign history over specific time periods. Beginners sometimes forget to handle missing values or misinterpret categorical scales. Always check what each column means and how time and responses are structured before analyzing market trends. Running the cell now. We will start with an online retail transactions dataset to explore sales trends. Let us use a real, public retail dataset focused on online purchases. We load the dataset directly from the UCI repository. We focus on the sheet with transactions from 2010 to 2011. It is important to parse the invoice dates as datetime objects. We print the number of records and columns for a sense of scale. Let us preview the first 3 transactions to check the data format. Running the cell now. This output shows the online retail dataset contains over 540,000 rows and 8 key columns, including transaction details like invoice date, quantity, price, and customer ID. Notice the data captures both categorical fields, e.g., stock code, country, and numeric fields, quantity, price, with timestamps standardized as datetime objects, crucial for analyzing sales trends over time. This initial data overview confirms the dataset structure and readiness for exploring customer purchase behavior and market dynamics. Practice: how many total rows are there, and what does each row represent in business terms? Let us analyze how the number of purchases changes over time, a basic market trend. We add a column to extract the month and year from every invoice date. Next, we count how many transactions happened in each month. Grouping by month shows the total market activity for each period. We plot this as a line chart to clearly see peaks and dips. This title explains what we are plotting: monthly transactions. The y-axis shows how many purchases occurred. The x-axis shows the timeline month by month. Finally, we display the sales trend plot. Running the cell now. This line plot shows the monthly transaction counts, revealing sales trends over time. Notice any peaks or dips, which could indicate seasonal effects or campaign impacts. The code's goal is to practice summarizing time-based purchase data, an essential step before deeper market analysis. Try this: what real-world events or seasons might explain the sales peaks or dips? We will now shift to a customer satisfaction survey dataset with churn data. We load a real customer service dataset from OpenML. The dataset contains information about each customer and whether they stayed or left. Print the shape so we know how much data we have. Preview columns related to customer tenure, monthly charges, and churn outcomes. Running the cell now. This output shows the dataset contains 7,043 rows and 20 columns, indicating a sizable survey with multiple variables. The preview highlights key columns: tenure, customer duration, monthly charges, billing amount, and churn, whether the customer left, which are essential for analyzing how satisfaction and churn relate over time. Notice the mix of numeric and categorical data here, reminding us to interpret each column type carefully when studying market trends. Question: why is the churn variable key to forecasting market retention? We want to see how likely customers are to churn based on how long they have stayed. Create tenure groups that break customers by months. Calculate churn rates for each group using value counts normalized to percentages. Display the churn trend table for each tenure category. Running the cell now. This output shows the proportion of customers who churn or stay, nova churn, across different tenure groups, split by time intervals in months. Notice the clear trend: churn rates, the yes column, steadily decrease as customer tenure increases, indicating longer tenured customers are less likely to leave. This demonstrates how grouping numeric tenure data and calculating normalized counts help reveal meaningful patterns in customer retention over time. Practice: which tenure group seems most at risk for churn? Why might that be? Let us visualize the churn rate for customers in each tenure group. A bar plot shows the churn rates for customers who left, by tenure range. This title explains what we are showing. The y-axis displays the proportion who have left, churned. The x-axis shows how long customers have been with the company. Set y-axis to scale between 0 and 1 for easier interpretation. Show the chart of churn rates by tenure. Running the cell now. This bar chart shows how the churn rate varies across different customer tenure groups, clearly highlighting the trend of retention over time. Notice how the churn rate, proportion of customers who left, is represented on the y-axis, with tenure groups on the x-axis, helping us spot which tenure segments are at higher risk. This visualization emphasizes the importance of segmenting customers by tenure when analyzing churn patterns in market research data. Ask: what might a business do if new customers churn more? We will now use a dataset from a bank's marketing campaign to study campaign effectiveness. Load a real campaign response dataset from OpenML. Rename columns for business clarity. Get a sense of the total data. Preview the campaign month and response indicator. Running the cell now. This dataset contains 45,211 records and 17 columns capturing customer demographics, campaign interactions, and responses. Notably, the month to column is categorical, indicating when contacts occurred, while response shows a binary outcome for each customer. This setup is key to exploring how timing and customer features relate to campaign success, emphasizing the importance of understanding column meanings before analysis. Let us analyze how campaign response rates change by month, revealing marketing trend effectiveness. Group by campaign month and calculate response rates. Show the monthly response rate table to spot trends in campaign success. Running the cell now. This output shows the proportion of two types of campaign responses, coded as 1 and 2, for each month, revealing clear month-to-month variation in response behavior. Notice how some months like May and July have very high rates of response type 1, while others like March and December show a more balanced or even higher rate of response type 2. This helps highlight trends in campaign effectiveness and seasonality, illustrating why it's crucial to aggregate and normalize responses before interpreting market engagement over time. What patterns do you notice in campaign response rates over the year? We visualize the positive, yes, campaign response rates month by month. Bar plot makes it easy to spot which months had the most success. Label the chart helpfully for presentations. Show the percentage of positive responses for each month. Label the campaign months. Set the axis limits for clarity. Display monthly campaign trend. Running the cell now. This bar chart shows the monthly yes response rates for campaign 2, with rates ranging between 0 and 1 on the y-axis. Notice the variation in response rates across different months, which helps identify trends or seasonal effects in customer engagement. This visualization reinforces the importance of examining time-based responses to understand how campaign effectiveness changes over time. Think, why might some months perform better in marketing campaigns? Let us study trends in total revenue, not just transactions. Compute a new column for revenue per purchase. Sum total revenue for each month. Visualize the monthly revenue trend using a line plot. Title the plot for context. Label the y-axis to show revenue amounts. Label the x-axis as months. Display the revenue trend visualization. Running the cell now. This line plot shows the total retail revenue summed for each month, highlighting trends and seasonal patterns in sales over time. Notice the shape of the curve and key months where revenue peaks or dips, which helps identify periods of high or low customer spending. This connects to the lesson by illustrating how time-based transaction data can reveal important market dynamics through proper aggregation and visualization. Try, does revenue follow the same pattern as transaction counts? Why or why not? Businesses often want to know what countries drive most growth. Group revenue by both month and country for segmentation. Identify the 5 countries with the most revenue over this period. Plot trends for those countries for an international market comparison. The plot title makes it clear what is being compared. Y-axis displays total revenue. X-axis is the month. Legend identifies each country's trend line. Show the segmented trend visualization. Running the cell now. This monthly revenue trend plot breaks down total sales by country, highlighting the top 5 markets by overall revenue. Notice how the time series shape reveals seasonal patterns and growth differences across countries, which is crucial for cross-market comparisons. This visualization helps identify key revenue drivers and informs targeted strategies by showing how each country contributes over time. Practice. Which countries show clear seasonality or sudden spikes? We segment customers by how much they pay to analyze financial risk trends. Group monthly charges into price ranges. Compute churn rates for each price group using value counts. Visualize the churn trend by monthly charge category. Title clearly shows context. Show proportion of churn for each group. Label each charge group. Keep y-axis scaled between 0 and 1. Show the results. Running the cell now. This bar chart shows the churn rate across different customer groups based on their monthly charges, categorized from low to very high. Notice how churn tends to increase with higher charges, indicating a potential trend where customers paying more are more likely to leave. This visualization highlights the importance of segmenting numeric data into meaningful categories to reveal trends in customer behavior for market research. Experiment, for which segment is the churn risk highest? What would you recommend? Net Promoter Score, NPS, helps businesses gauge customer loyalty trends. Set the random seed for reproducibility in synthetic data. Create a synthetic dataset for NPS by region. Calculate the average NPS per region. Bar plot visualizes loyalty differences across regions. Title the plot for clarity. Label the y-axis as average NPS. Label the x-axis with region names. Scale y-axis from 0 to 10, the NPS score range. Display NPS regional trends. Running the cell now. The bar chart displays the average NPS score segmented by region, illustrating how customer loyalty and satisfaction vary geographically. Notice the distinct differences in height among the 4 regional bars, which helps identify potential market strengths or areas needing improvement. This visualization supports the lesson's focus on interpreting categorical groupings and numeric survey responses to uncover meaningful trends in customer feedback. Think, what actions might a company take if one region falls behind in NPS? Let us check whether younger or older customers respond differently to marketing campaigns. Segment ages into business-friendly bands. Calculate the campaign yes rate for each age group. Plot age group response rates using a colored bar chart. Title the plot for business readers. Y-axis is the likelihood of a yes response. Label the x-axis with each age group. Keep response values scaled 0 to 1. Show the segment response chart. Running the cell now. This bar chart displays the proportion of yes campaign responses across for age segments, revealing how customer willingness varies by age group. Notice the clear differences in positive response rates, which helps tailor marketing strategies by highlighting which segments are more receptive. The code's intent is to segment by age and compare response behavior, emphasizing the importance of categorical grouping and normalized counts in market research analysis. Challenge: would you spend more campaign budget on one age segment? Business analysts often smooth trends to detect real changes, such as seasonal sales booms or drops. Calculate a 3-month moving average for smoother trend detection. Begin a figure for overlay plotting. Plot raw monthly revenue. Add the moving average for comparison using a dashed line. Clearly title the graph. Label y-axis for revenue. Label x-axis as month. Show which line represents which metric. Display the combined trend plot. Running the cell now. This plot shows the monthly revenue alongside its 3-month moving average, smoothing out short-term fluctuations to highlight underlying trends. Notice how the moving average line helps detect recent sales peaks or declines more clearly, which is crucial in market research for timing promotions or understanding customer behavior shifts. This reinforces the lesson's point about carefully interpreting time-based transaction data to reveal meaningful patterns. Try: which months mark significant turning points in performance? Forecasting future trends lets businesses plan resources and set expectations. Import a simple regression model to fit trends. Prepare a months index for regression. Initialize the linear model. Fit model to months and revenue history. Create data for the upcoming month. Predict next month's revenue with the trend model. Print the forecasted revenue for strategic planning. Running the cell now. This output shows a predicted revenue value of about $990,363 for the next month, generated by fitting a linear regression model to past monthly revenue data. Notice how the code uses monthly intervals as the predictor and actual revenues as the target, illustrating how simple time-based trends can forecast future sales. This reinforces the lesson's focus on understanding temporal market data and the importance of modeling trends before making predictions. Exercise: what might cause actual revenue to miss this trend forecast? Customer cohort analysis tracks retention and engagement trends over time. Set a seed for reproducibility in synthetic data. Define the time range for recruitment. Create synthetic customer cohort activity counts month by month. Set sign-up date as the index for easy plotting. Plot the timeline of active customers. Label y-axis for number of active users. Label x-axis for monthly cohorts. Show cohort trend plot. Running the cell now. This line plot shows the trend in active users for customer cohorts based on their sign-up month, highlighting fluctuations in retention over 2 years. Notice the monthly x-axis and the variation in active user counts, which reflects how cohort engagement changes over time. This helps illustrate how time-based customer data can reveal retention patterns essential for understanding market dynamics. Practice: what kinds of business actions follow if retention trends decline sharply? Missing survey values can distort market trend analyses. We copy our survey data to simulate missing churn responses. Randomly set about 5% of churn values to missing to reflect real situations. Print how many churn entries are now missing. Fill missing churns with no as a simple, conservative approach. Display before and after filling the missing values. Running the cell now. This output shows that 352 entries in the churn column are missing after simulating incomplete survey responses. Filling these nouns with no creates the new churn_filled column, ensuring no missing values remain and preserving categorical consistency for further analysis. This step highlights the importance of handling missing data in customer behavior variables before interpreting market trends. Ask, when is it not safe to simply replace missing survey answers with the most common value? It is easy to mistakenly group by an identifier that does not give business insight. Try grouping NPS by unique customer ID, which does not reveal market trend. Print the result, even if it is not meaningful. If an error occurs, catch and print it. The correct grouping is by business segment, such as region. Now print the correct average NPS by region. Display the valid market segmentation. Running the cell now. This output shows the difference between an invalid and a correct aggregation approach, NPS scores averaged by individual customer ID versus by region. Notice the first result lists raw scores per customer, which isn't meaningful for broader trends and might be misinterpreted, while the second correctly summarizes average NPS by region, revealing clear regional differences. This highlights the lesson's point to group by meaningful categorical variables for insights, avoiding aggregation mistakes in market research data. Prompt: what would you look out for to avoid meaninglessly granular groupings? Misreading the Net Promoter Score scale leads to mistakes. Promoters are customers who score 9 or above. Detractors score 6 or below. Summary table shows the true proportion of loyal and unhappy customers by region. Running the cell now. This output shows the average proportion of promoters and detractors by region, highlighting key customer sentiment differences across markets. Notice how the detractor values are much higher than promoter values, indicating a possible misinterpretation or an unusual distribution of NPS scores. This reinforces the lesson to carefully define NPS categories, as confusing the scale can lead to misleading market insights. Practice: what if you averaged NPS scores without distinguishing promoters and detractors? Market research analytics best practices. Segment your data by meaningful customer attributes, like tenure, charges, or region. Cross-tabulate outcomes to compare segments and trends over time. Construct scores such as NPS or churn rate using standardized business rules. Always visualize trends to spot real business shifts, not just random noise. Document your assumptions and investigate possible causes behind trend changes. Running the cell now. Segmentation helps you compare outcomes for business-relevant groups. Group campaign responses by customers' education. Display the table of yes and no response rates by education segment. Running the cell now. Here, the code segments campaign responses by education level, showing the proportion of positive, 1, versus negative, 2, responses within each group. Notice how higher education levels correspond to a larger share of negative responses, highlighting meaningful differences in engagement. This output reinforces the importance of segmentation to uncover distinct customer behaviors that inform targeted marketing strategies. Try which education segments are most receptive to campaigns. Cross-tabulation provides deeper business insights by comparing multiple attributes. Show churn rates across both tenure groups and status for a complete view. Running the cell now. This cross-tabulation shows the proportion of customers who churned or stayed within each tenure group, revealing a clear trend: churn rates steadily decline as tenure increases. Notice how newer customers, 0 to 12 months, have nearly a 48% churn rate, while long-tenured customers, 61 to 72 months, have under 7% churn. This highlights the importance of segmenting by tenure to identify which groups are at higher risk and require targeted retention efforts. What other crosstabs could you use for actionable insights? Business indexes quantify trends for easy monitoring over time. Here we build a sales index by dividing each revenue value by its moving average. The final rows show how recent months compare to average trends. Running the cell now. This sales trend index compares each month's revenue to its recent average, highlighting relative changes in sales performance over time. Notice the index fluctuates around 1, with spikes in September to November indicating stronger sales, while December's sharp drop signals a significant downturn. This visualization helps identify meaningful trends rather than random noise, supporting better market segmentation and decision-making. Try, a value above 1 means sales are above average. How would you present this index to management? Now let us solve an end-to-end business problem. Select customers with high monthly charges to focus on those most valuable. Group these high-value customers by tenure and count churns. Convert tenure groups for plotting. Start a new figure for the bar chart. Draw a bar chart for the number of churned customers in each group. Title the plot to describe what is being forecasted. Label the x-axis as tenure groups. Label the y-axis as the count of churned customers. Show the chart for business review. Capture the most recent group's churn value for practical planning. Print how many high-value customers churned in the latest group. Summarize the recommended business action. Running the cell now. This chart breaks down churn counts by customer tenure for those with high monthly charges, highlighting which tenure groups have the most churned customers. Notice the latest period shows 80 churned customers, indicating a key segment to focus retention efforts on. This segmentation and visualization help pinpoint where to prioritize interventions, aligning with best practices for actionable market research analytics. Practice: how would you track whether your retention effort improved next month's churn? To support your learning journey, find more free tutorials and market analytics strategies on YouTube.